Hi everyone, myself and Arun from SS College of Technology. In this video, we are going to discuss about steady-state error constants. So there are three type of systems we are having in steady-state errors. First one is type 0 system, second is type 1 system, and type 2 systems. It can be calculated based on the error constants, especially for type 0 systems. It is a zero value. It can be calculated by 1 plus k. It is a zero type 0 system, so it doesn't have any values for the transfer characteristics equations. For type 1 systems, it is in the order is having only one s power, and here the s power n value is 1, so that we can choose it as s1. S value is used for this type 1 systems. For type 2 system, s power value will be 2, so that we can use the characteristics equation for finding the static error constants. It can be implemented for any kind of step signals, ramp signals. Here the unit ramp systems for the static velocity error can be followed by limit s tends to 0 s divided by 1 plus z of s into 1 by s square, so that we can get 1 by s into z of s. The static velocity error constant kv is velocity error constant can be defined by limit s tends to 0 s into z of s, because it is a type 1 system, so then we can choose s power value 1. So type 0 system, type 1 system, type 2 system, the differentiate between these three systems as notified as uh, initially type 0 system doesn't have any s value, but in this case of type 1 s power value 1. For more order or type more than 2, we can use for s power n. It can be comes under type 2 systems. For more than n value is 2, we can use for type 2 systems for finding a error constants. For ramp input signals, how the type values has been varied with respect to steady state errors. In this steady state error, type 0 system is 1 by kV. So next one is type 1 system, 1 by kV equal to 1 by k. For type 2 system, it may be a 0. So in this acceleration and position velocity has been calculated based on the type of the corresponding systems. Here the static acceleration constants can be calculated by s square into g plus. Velocity also calculated by 1 by kv. For a parabolic input, the steady state errors is notified as, because almost all the values which are used in parabolics are characteristics equations, because more number of s can be calculated, one in the form of parabolic functions. So it is one of the main parameters in control systems to find the error constants. First one is static error constant for infinity is used for type 0 and type 1 systems. If it is type 2 system, type 2 system, it can be used as 1 by k. If it is used for more number of order or type 3, it can the statistic error is 0. So let us consider an example of control system is having a steady state errors. If it is having error, then automatically it can pass towards the input signal. Then we can find out the error signal in the middle of the input signal and the transfer function, so that it can passes to the output signal without any delay of the corresponding equations. The following table shows the steady state errors and error constants for standard input signals. The following parameters are default equations which is used for step signals assessment. The following diagram shows how much steady state errors and how it is changed for different values of the static error constants. Initially, they are given the g of s transfer function of the system. We can calculate it based on the acceleration, position, and velocity errors. So initially we can calculate positional errors. Automatically we know that the default equation of positional error is limit s tends to 0. It doesn't have any s value, so that the positional error is infinitive. Next one is velocity error. Already we know that the formula is s into g of s because it's a type 1 system. So after substituting all the values, we can get the velocity error as infinitive. Next one is acceleration. It is a type 2 system. Then automatically the s value will be s square into g of s. If it is substitute all the values, then finally we can get 10.4 as a acceleration value, acceleration error constants. So like that, all the errors value has been calculated based on the standardized equations. After calculating all the equation, we can calculate the gain of the corresponding transfer function based on the error state, static error constants. So finally, we can get the static error constant for all the values as 0, 0, and zero point 0. Thank you.